Today, my topic is about what is a pH meter. So, we are going to start with the history of a pH meter. In 1909, the Danish chemist Søren Peter Lauritz Sørensen introduced the concept of pH at the Carlsberg Laboratory, originally using the notation pH with H plus as a subscript to the lowercase p. The concept was later revised in 1924 to the modern pH to accommodate definitions and measurements in terms of electrochemical cells. So, now we are going to see what is a pH stands for. pH stands for potential of hydrogen or power of hydrogen. A unit of measure that measures the acidity or alkalinity of a solution using a logarithmic scale with 7 as neutral, where lower values are more acidic and the higher ones are more alkaline, is known as pH. The pH equals negative log 10 of the hydrogen ion concentration given in moles per liter. pH is equal to minus log H plus. Now we are going to see what are the uses of a pH meter. A pH meter is a scientific instrument that measures the hydrogen ion activity in water-based solutions, indicating its alkalinity or acidity expressed as pH. It is generally used to measure the pH of aqueous solution. The pH of a solution depends on pH scale, which is used to measure the perfect pH of the solution. Next, we are going to see what is a pH scale. pH scale is divided into 3 parts: acidic, neutral and alkaline. The range of pH value lies in the range of 0 to 14. Water is considered a neutral solution with a pH value equal to 7. The pH value of the solution in the range 0 to 7 is acidic and 7 to 14 is basic in nature. Basically, pH is inversely proportional to the concentration of H plus ions and directly proportional to the concentration of OH minus ions. In this table, we can clearly see the difference in the values of pH according to the solutions. Okay, now we are going to see what are the most important parts in a pH meter. First one are the electrodes. They are divided into two, reference and a glass electrode. Next one is the glass membrane, then the filling hole, then electrometer or voltmeter, then glass probe, and finally a diaphragm. Glass electrode. The difference in electric potential can be measured using a glass electrode. It has a sensitive glass bulb at the end. It is made up of silica. The tip and filament is made up of silver chloride. It is filled with 0.1 hydrochloric acid. Now we are going to see what is a reference electrode. It is a metallic conductor. The filament is made up of silver chloride. The tip of the filament is made up of mercury chloride. The electrolyte filled in the electrode is saturated potassium chloride. Provide a stable zero voltage connection, insensitive to the pH of the solution. The pH value of the glass electrode is 7 and the pH of the reference electrode is insensitive. That's the main difference between the glass electrode and the reference electrode. Now we are going to see what is an electrometer or a voltmeter. It measures the minimal differences in electric potential. When voltage increases, less H plus ions, more OH minus ions, acidity decreases, pH increases. When voltage decreases, more H plus ions, less OH minus ions, acidity increases and the pH decreases. Now we are going to see what is a filling hole. Used to refill the electrolyte in the electrodes. The glass electrode and the reference electrode are filled using the filling hole. The diaphragm. The diaphragm on a pH electrode allows the flow of electrolyte from the reference solution into the solution being measured. This completes the electrical circuit between the reference and sensing electrode and gives the potential difference. Now we are going to see what is a glass probe. Present at the bottom part, which is a sensitive bulb-shaped glass membrane where the ion exchange takes place. With this, we are coming to an end of the parts present in a pH meter. Now, we are going to see how does a pH meter work. The potassium chloride inside the glass electrode, which is orange in color, is a neutral solution with a pH of 7, so it contains a certain amount of hydrogen ions. Suppose the unknown solution you are testing is much more acidic, so it contains a lot more hydrogen ions. What the glass electrode does is to measure the difference in pH between the orange solution and the blue solution. By measuring the difference in the voltages, there are hydrogen ions produced. Since we know the pH of the orange solution, we can figure out the pH of the blue solution. So now, you dip the two electrodes into the blue test solution. Some of the hydrogen ions move towards the outer surface of the glass electrode and replace some of the metal ions inside it, while some of the metal ions were moved from the glass electrode into the blue solution. This ion swapping process is called ion exchange. The ion swapping also takes place on the inside surface of the glass electrode from the orange solution. The two solutions on either side of the glass have different acidity, so a different amount of the ion swapping takes place on the two sides of the glass. This creates a different degree of hydrogen ion activity on the two surfaces of the glass, which means a different amount of electric charge builds up on them. This charge difference means a tiny voltage between the two sides of the glass, which produces a difference in voltage between the silver electrode and the reference electrode that shows up as a measurement on the meter. The meter shows the actual difference between the two liquids with which we can measure the pH of the solution. So, this is how we can measure the pH of a solution. Now, we are going to see the types of the pH meter available to us. There are mainly two types of pH meter, a digital pH meter and a manual pH meter. The digital pH meter is much more easier to handle compared to the manual pH meter, which can be carried everywhere in our hand. The other types of pH meter available in the market can be seen in the image. Now we are going to see how we can handle a pH meter, a manual pH meter. First, we are going to turn on the pH meter. Next, we are going to rinse the electrode with distilled water, then wipe it with a tissue paper. Next, we are going to prepare the buffers used in the pH meter. Next, we are going to calibrate our pH meter. Place the electrode in the buffer with pH 7. Set the pH, then rinse the electrode with the distilled water. Then again place the electrode in buffer, set the pH and again rinse the electrode. By setting the pH in the buffer 2 times, we can calibrate our pH meter. Next, we are going to use the pH meter to measure the pH of our solution. Place the electrode in the sample, then measure the pH after 2 minutes. Then rinse it with distilled water and try it. This is how we measure the pH of the solution with the pH meter. Now we can see the various applications of a pH meter. The pH meter is used in the agricultural sector because the soil pH is important for the growth of the crops. Monitoring pH level is essential in water treatment facilities and raw water purifiers. Chemical industries use pH meter to neutralize wastewater from steel, pulp, paper, etc. A pH meter determines the pH value of chemical compounds and food products to ensure their quality and safety. To determine the type of biological conditions by measuring the pH of biological fluids such as blood, urine, gastric acid, etc. Thank you for your patient listening. Thank you.